All right. Hello friends, welcome again. So today we will going to discuss bloom filters. So if you're new, so this is a high level design series. So we already discussed all these topics, basic concepts, building blocks. So right now today's topic is bloom filters. And if you're new, so subscribe this channel and we will discuss like we are discussing a high level design topic just like as our next topic would be Kafka, like message queue, right? Even driven things. So we have to discuss a lot of things, sockets, this and that, and again we have very important thing trade-offs, right? Very important trade-offs, right? And then we're gonna discuss lower level design as well. Very important for the interview, right? So okay, let's come back to the Bloom filters. So I already prepared the notes and I will attach the uh, notes link in the YouTube description as well. So let's get started. What is Bloom filter? So, view full page. Okay. So, Bloom filter in high level design. So, what is Bloom filter? Bloom filter is a space efficient data structure used to quickly answer. Okay. What does it means? Sorry. So basically, two things. Okay. It says either present or either probably present or not present. Okay. So if the case is not present, it's 100% correct. Okay. But if the case is probably probably present, so either present or not present, but it consumes capacity. It consumes capacity. So two things. I already wrote it here. Definitely not present, possibly present. It can never guarantee an element is present, but it can guarantee an element is absent. Okay. So example, instead of checking in security at large airport, instead of instead of checking every passenger, right? Every passenger has a huge database. Security first check a tiny memory efficient Bloom filter. If it says not present, immediately allow. Possibility present, perform expensive database lookup. Okay. So overall, it saves massive competition and database load. We'll discuss going forward in deep. What does it means? So why do company use simple cache validation? Suppose someone hits user slash 9999 something. We know doesn't exist, right? Now, without Bloom filter, what will gonna happen? Request will come to the Redis, it will say miss, then it will come to the database hit, then it will say not found, right? Suppose we gonna have okay billions of invalid requests can overload the database. Simple, right? So if we are sending millions of requests, right? In that case, that will be down. Simple, right? So in that way, in there we are using Bloom filters. Now, what will Bloom filter do? First of all, request, go to Bloom filter. It will say definitely no present. So it will say return 404. Database never get hit. Okay, very important. So request, Bloom filter. Okay, result return from here. So here we have DB never hit. Okay, DB never hit in case of not present. So we'll discuss how it says not present, right? So now internal structure, how it works. Internally, it deals with bits, right? 0, 0, 0, 0, 0. Now suppose user 1, 2, 3. So internally, what it does, it stores bits 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now suppose first user it getting processed, user 1, 2, 3, it will compute hash. Okay, it will compute hash, and suppose after computing hash, we got index 2. Again it computes hash, we got index 5. It again it computes hash, we got index 8. Right. So what it will do? It will make 1, 0, 1, 2. So I'm just places, right. It will write 1, 0, 1, 2, 3, 4, 5. So here it will put 1, 6, 7, 8. So here it will put 1. Okay. So we're gonna have this array, bit array, 0, 0, 1, 0, 0, 1, 0, 1, 0. Okay. Now we'll discuss how it works. First of all, in a user, it hits hash method, and now we get this thing, right? After that, suppose, okay, so I already discussed this thing, how it generated 0, 0, 1, 0, 0, 1, 0, 1, 0. Now, search operation, meaning how it works internally, right? Now we had 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. Now, it was for user 1, 2, 3. Now, another user came, meaning we have new request user 999, and hash get computed 147. Okay, 0, 1. Let me write like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna have 0, 1, 2. Okay, so here we have 1, and here we have 1, right? So this is a request, but we have present this user. So immediately it will say, because bits are not matching, right? It will go with only number 1 bit only, right? So immediately it will say definitely not present. This is a key advantage. Okay, this is a key advantage. So this way, this is a way for the insertion and searching, right? So it will right away it will say not present. Right away it will say not present. Okay. So we discussed two cases, right? So one was not present. Okay, so one was not present, which we discussed here. Now, second case was possibly present. So now discuss that case. User A has these three hash 2, 5, 8. User B has 1, 5, 9. Okay, so suppose 2 Users are present. User 1, 2, 5, 8. User 2 with 1, 5, 9. Now, suppose request came with user 3. 1, 2, 8. Okay. So this is present, this is present, but this is not present. But how it works? It will say, it will check. One is present, so we'll get this. Yeah, one is here. It will check. Is two present? It will say yes, two is present. It will check. It is present. It will check. It, yes, it is present. So because it doesn't know, like these bits are like these bits are for user one, these bits are user, but it will check only bits, right? Just like as these bits. If it got 111, it means it will say yes, possibly present, possibly present. So now here all bits happen to be set. Bloom filter says possibly present. Now when possibly present, it will, but we haven't inserted this, but somehow we'll get is present. This is a false positive. This is a false positive. Actually not present, but Bloom filter says present. So it will go again request Bloom filter. It will come to, it will say possibly present. Then Redis or whatever cache you are using, it will say miss. Then DB hit, it will say 404. So with the, it will, it's a false positive case, right? DB hit is there, ready cache is there, so it consumes our cycle. Okay. So it is the best for not found, but false positive also there. I'm checking my pen drops down. Okay. So important rule. Bloom filter guarantees. So Bloom filter guarantees false positive, yes, false positive, no. Okay. So if Bloom says not present, it means 100% you can just not present. So, mainly the very good case for Bloom filters are we are checking 100%, sorry, we are checking not present. Like it is very good for not present case. So high level architecture. Client will, like request is coming from client, then API gateway, then Bloom filter. If not present, write a 404. If maybe, then Redis, database, whatever I explained earlier, right? So protection use case. Database protection, right? Prevents invalid lookups from reaching DB. But we discussed, right? Web crawlers, crawlers. Search engine must avoid revisiting URLs. Visited URL, Bloom filter check instantly, used by Google, Microsoft. Okay. Now, distributed cache system. Before Redis lookup, check Bloom filter, avoid cache penetration attack. What have we discussed? Right, the same thing. Cache penetration meaning client, I can say request, then Bloom filter, it will send the result. Our Redis or cache, another cache, our DB, this layer is hidden, right? Not hidden meaning the request will not gonna come here. It will filter out from here in case of 404. Okay. So e email spam detection. So sometimes we get the answer right away, right? Email not found. So same blue filter is used there. Cybersecurity and capacity planning example. Suppose 100 million user. So traditional asset we gonna it will be used. It will get 2 to 4 GB. But blue filter will be using only 120 MB. Okay, so that's why we are using Bloom filters. Now, interview questions. Now, I hope you understand the Bloom filter, right? Why use Bloom filter instead of hash set? Because of less memory and provides 0 1. But instead of only false, positive, or positive. Trade off here is false, positive, or possible. Can lead item? No. So here, because clearing a bit may affect other elements, in that case, we can use counters, store counter instead of bits. Okay. Then we can remove, meaning we have 0, 1, 2, right? So if you want to remove anything, suppose we have to remove from this part, it will be like this. Simple. Okay. So in one line definition, Bloom filter is a memory efficient gatekeeper that can quickly tell us if data definitely doesn't exist, helping companies save millions of data based queries every second. So this is the main line, right? Main detail. Okay, so I think you already understand details. This is the main answer, right? Bloom filters. So by this, we are closing. I'm closing this video. And again, if you're new, then you can subscribe the channel. And going forward, we're gonna discuss a lot of hello design as well. So for now, I can say have a good night and bye for now.